Not all asteroids are created equal. Some are harmless pebbles, others are mountain-sized monsters that could reshape our planet. These ancient wanderers, leftovers from the solar system's birth, have shaped Earth since its formation. They've delivered water and the building blocks of life, but also unleashed destruction, resetting evolution's course. The threat is real, a constant cosmic reality we're only now beginning to understand. Today, we'll compare what would really happen if asteroids of different sizes hit Earth, and how our planet would respond. This is the story of impact, destruction, but also resilience. Earth is bombarded daily by over 100 tons of cosmic dust, most no bigger than grains of sand. These particles burn up high in the atmosphere, creating shooting stars, harmless, beautiful reminders of the universe beyond. Our atmosphere vaporizes them completely, protecting us from harm. But scale up to a 1-meter rock and things get more dramatic. Too big to burn up, it becomes a fireball, sometimes exploding mid-air with the force of a small bomb. The shockwave can rattle windows, but rarely causes real damage. Occasionally, small meteorites survive the descent, offering scientists clues about the early solar system. These events are rare and mostly harmless, thanks to our atmospheric shield. The fragments that reach the ground are prized scientific treasures, time capsules from space. For the most part, Earth's defenses are more than adequate against these tiny invaders. The daily rain of dust and the occasional fireball are just part of life on a living planet. But as we increase the size of the impactor, the atmosphere's protection fades, and the consequences grow. The gentle rain is about to become a storm. Now imagine a 20-meter asteroid, like the one that exploded over Chelyabinsk, Russia, in 2013. This 6-story rock, weighing over 10,000 tons, entered the atmosphere at 60,000 kilometers per hour. It became a blinding fireball, brighter than the sun, before violently disintegrating 30 kilometers above the ground. The explosion released energy 30 times greater than the Hiroshima bomb. The shockwave shattered windows in thousands of buildings, injuring over 500 people, mostly from flying glass. The main body never reached the ground. The atmosphere absorbed its energy, but the blast still caused chaos. Chelyabinsk was a wake-up call. Even a small asteroid can cause mass injuries and widespread panic. It arrived with no warning, highlighting a critical blind spot in our planetary defense. City destroyer asteroids don't need to hit the ground to wreak havoc. They remind us that even small space rocks can have devastating consequences. Now scale up to a 100-meter asteroid, too massive for the atmosphere to stop. On impact, it would unleash energy equal to thousands of atomic bombs, vaporizing everything at ground zero. The resulting crater would be over 1 kilometer wide. A city would be obliterated in an instant. A superheated blast wave would flatten buildings for tens of kilometers, while molten rock would rain down far beyond the impact site. The ground would shake with the force of a major earthquake. If it hit the ocean, a mega tsunami could devastate coastlines thousands of kilometers away. Events like this are rare, once every few thousand years, but inevitable on geological timescales. The 1908 Tunguska event, which flattened Siberian forest, was likely caused by a slightly smaller object. That's why objects of this size are a top priority for planetary defense programs. Astronomers are working to find and track every near-Earth object of this scale. A 100-meter impact wouldn't end civilization, but it would be a disaster unlike anything in modern history. Now consider a 1-kilometer asteroid, a true civilization changer. Its impact would create a crater up to 20 kilometers wide and devastate everything for hundreds of kilometers. But the real danger is global. Millions of tons of dust and soot would block sunlight, plunging Earth into an impact winter. Temperatures would drop, agriculture would collapse, and famine would spread worldwide. The global economy would unravel, and ecosystems everywhere would be pushed to the brink. Photosynthesis would stall, collapsing food chains on land and in the sea. This artificial winter could last for years, leaving a harsher world in its wake. The good news? Asteroids this large are easy to spot, and over 95% have already been mapped. None are on a collision course with Earth for the foreseeable future. Our knowledge is our shield. By finding them, we've diffused the threat, for now. Now the ultimate impact. A 10-kilometer asteroid, like the Chicxulub impactor that struck 66 million years ago. The energy released was unimaginable, 10,000 times all the world's nuclear bombs combined. The impact vaporized rock, carved a 200-kilometer crater, and unleashed a fireball that incinerated life for 1,000 kilometers. Mega tsunamis scoured coastlines, and the seismic shock triggered global volcanic eruptions. But the real killers were the aftermath. Sulfur and soot blocked sunlight, plunging Earth into darkness for months or years. Photosynthesis stopped, plants died, and the food chain collapsed. 75% of all species, including the dinosaurs, vanished. The Chicxulub impact reset evolution, paving the way for mammals, and eventually, us. Events like this are extremely rare, but they've happened before, and physics says they could happen again. Chicxulub is the benchmark for cosmic catastrophe. Can it get worse? Yes. In Earth's early history, impacts were even bigger. Imagine a 50-kilometer asteroid. Its impact would rupture the crust, boil oceans, and send superheated steam around the globe. The shockwave would trigger planet-wide volcanism, and the atmosphere could be stripped away. Life on the surface would be wiped out. Only deep-dwelling microbes might survive. Scale up further, and a Ceres-sized impactor could shatter the planet, creating a new asteroid belt. This is how our moon likely formed when a Mars-sized body struck the early Earth. These are events of creation and destruction, shaping the solar system's infancy. Today, the orbits of such giants are stable and pose no threat. The era of planet shatterers is over. We study these relics for science, not fear. For billions of years, Earth faced impacts alone. Now humanity is changing that. We've built a global network of telescopes to find and track asteroids. Knowledge is our first line of defense. If we know an impact is coming, we can act. In 2022, NASA's DART mission proved we can nudge an asteroid off course. DART crashed into Dimorphos, changing its orbit, a proof of concept for planetary defense. ESA's Hera mission will study the aftermath, refining our techniques. Other ideas, like gravity tractors, are being explored. Understanding the threat, finding the objects, and developing deflection technology are our best insurance. The story of asteroids is no longer just about destruction, it's about human ingenuity and responsibility. We are the first generation capable of defending the planet. From harmless dust to world-ending impacts, asteroid threats exist on a terrifying scale. Each step up in size brings new levels of destruction. For eons, survival was luck. Now, we have the tools to see and act. The dinosaurs never saw it coming. We can be different. Our vigilance is a duty to the past and a responsibility to the future, because when you compare asteroids, you realize size isn't just a number,